I got stuck with data structures as an online.
And with, first of all, when you're doing absolute value, okay, I want to just show you kind of a quick way to do this. You'll encounter this from time to time in this class, and you see this in calculus and beyond, okay? Let me ask you a question on this number 15. In your head, can you tell me the answer? Okay, there's two answers. That's key. Okay, one of the answers is 10, and the other answer is negative 10. Okay, and that's basically from your background. You know, hopefully if you do an absolute value of a negative number, it's still positive. And then if you do an absolute value of a positive, it's positive, right? So there's two answers. So typically when you're doing an absolute value equation, you almost always get two answers. There's exceptions to that. So what I want to do is kind of give you an example on this 16, and then I'm going to leave 17 just for you to do. Okay, the first thing that you want to do when you do an absolute value equation is you always want to isolate the absolute value. So what I mean is this part of the problem needs to be by itself. Okay, so you want to make that 2 go away. How do you do that? You subtract 2 from both sides. Or you can just move the 2 to the other side like that. Okay, so one of the things that you'll see me doing a lot when I solve equations, and I don't care if you do this step in your head, but you're subtracting 2 from both sides or moving that. So now what you have is 6x plus 3 is equal to 4. Okay, now anytime that you have an absolute value of something, there's 2 possible answers. Okay, you got to figure out what makes this 4 or what makes it negative 4. Does that make sense? Okay, if you can figure out what value of x makes that 4, you got one answer. If you can figure out what makes it negative 4, you got the other answer. Why negative 4? Because when you do the absolute value of negative 4, it's going to turn into that anyway. Okay, so what you do is after you isolate, then the next thing you do is you just set up 2 equations. Okay, and then I'm just going to have you set these up, and then we're going to solve these. So what you would do is you would do 6x plus 3 equals 4. You solve that equation. Then you would also do 6x plus 3 is equal to negative 4. Okay, so once you have that isolated, you're going to get your 2 answers by doing that. Does that make sense? Okay, be sure you isolate that absolute value before you do that then. Okay, and then what I'm going to do from here is I'm going to get rid of the 3, so I can subtract 3 from both sides. So that's 6x equals 4 minus 3. That's 6x equals 1. You can close that off by dividing by 6. So one of your answers is 1/6. Okay. You do the same thing over here. You can subtract 3 from both sides. So that's 6x equals negative 4 minus 3. So that's 6x equals negative 7. Then you can divide both sides by 6. So the second answer to that problem would be negative 7/6. Okay. So what you would end up having as your answer is you just write it as, with the set brace, negative 7/6 and 1/6 like that. Okay, and those are 2 answers to the problem. Does that make any sense what I just did? Is there any question about that? Okay, so the idea is that's what you're going to do is set that up. Let's go ahead and set up 17, and then I'll talk through how you finish it. What's the first thing you have to do on number 17? Got to isolate. So move the 8 to the other side. Okay, so we're going to have 5x minus 5 equals 4 minus 8. So that's going to end up giving 5x minus 5. I'm glad I did this problem because I just now realized I really need to talk about this a little bit, okay? All right, so I want you to look at this problem real carefully. Is it possible to take a number for x, work out 5x minus 5, get an absolute value, and get a negative number? Is that possible? No. So no matter what x is, this whole thing right here, since you're doing an absolute value, will never be negative 4. Does that make sense? So what do you think the answer is? There's no solution. Okay? So that one does not have a solution because of that. This is impossible to do an absolute value and get a negative number. So that one has no solution. Okay, that's the idea. So one thing that you want to kind of get used to is if you see an equation and you have an absolute value, and it turns out it doesn't matter what in the world's inside of it, if you have a negative, that can't happen. All right, is that sensible to everybody? Okay, now if you have a positive number, like if you had something like x minus 2 equals positive 4, then you're going to go ahead and get two answers. The way you get those two answers is by doing x minus 2 is 4, and what's the other one? X minus 2 is negative 4. So that's how you get your two answers. But the key thing you want to have down is if you have absolute value equals positive, we're going to get two answers. Okay? You have absolute value equals a negative, what do you get? Nothing. Does that make sense? Okay? You got to think about that when that pops up. Okay? Because that kind of thing will pop up from time to time. Okay? All right. Now, what I want to go through next is we want to do a little bit of review how you do equations with factoring and a little bit with the quadratic formula. Okay? So let's look at a few of these. First of all, if you have a quadratic equation, that means the highest power is going to be 2. So what you always want to do in this kind of equation is you want to make sure that that one side of the equation is 0. Okay? So move the x, move the 20. Now what you're doing is subtracting x and subtracting 20. So I'm just trying to get you used to just moving stuff. So that would be x squared minus x minus 20 is equal to 0. Okay? Now, you want to try to factor that. So if you need to brush up on your factoring, now's the time to do it because you'll do this throughout the semester. Okay, so your first term is x. So you have x and x. Your last term is 20. What would you use for 20? What's the right combination? 4 and 5, right? Okay, because 4 and 5 multiply to give 20. And then remember the inner term from FOIL and the outer term from FOIL have to add up to that middle term, negative 1x, right? So how do the signs go on the 4 and the 5? Plus 4 minus 5. Okay, so it goes like that. Okay, now what are the two answers to the problem? Negative 4, positive 5. Okay, so now that you got that worked out, you're going to just have negative 4 and positive 5 like that. Okay, once you get it factored, you're just setting each factor equals 0. We already did that a little bit last week. Okay. All right, what's the first step on 19? Move the 2 over. Okay, so you'll have 5x squared minus 9x minus 2 equals 0 like that. And then we want to go ahead and try to solve this by factoring. Okay, so if I do this one, the factoring is going to go like this. Okay, you're going to draw two parentheses. Your first term is going to have to be 5x and x. Your last term's got to be a 2 and 1, but it matters which order you put that in. So if I put it like this, a 2 and 1, then notice that inner term is 2x, that outer term is 5x, and you're trying to get that to add up to negative 9x. So that doesn't work, right? So what do? You just train the 2 and 1 around and see if it'll work. Okay, so there's a little bit of trial and error involved in that when you do that then. Okay, all right. So let's just change that around and let's see if we can get it to work now. Okay, so that would be 5x and x. Then we're going to have 1 and 2. The inside term is 1x. Outside term's 10x. Are you going to get a negative 9 out of that? Absolutely, because you'll have to have a plus 1 and minus 10 like that. So that means the signs go plus there and minus like that. So the answers to the problem are going to be what in your head? Negative 1 over 5 and 2. Okay, like that. Okay, are you guys okay with that? I got students with all kinds of different backgrounds in here. Some of you have already got it down. Some of you have been out of math for a long time. You guys want to make sure that I take the time to help you get this right. Yeah.
So the exam, do you want us to do like the answer just the way you're doing it, or?
Yeah, like if you're like doing my math lab when you start doing your homework, I think they make you put the two answers in a set brace. I think they already have the set brace for you. If you're doing a test, if you just tell me what the two answers are, that's fine. So you don't have to do that necessarily. That's kind of a proper way to write your answer to an equation.
Okay, so we're not supposed to do like 5x equal minus 1 and then we'll work out the x equal minus
Yeah, well, I'm kind of doing that part in my head.
Yeah, I mean, do you want us to show that?
No, you don't need to show that. Because to me, at this level of a class, you should be able to just do that. If you can't, then that's when you write that out, okay? Okay, I want to look at a couple other things here, okay, on this then. So I want to run through this quadratic equation. And what you want to do on this is you want to multiply that out. So you want to start by FOILing that out. Now, there's a couple of approaches you can do. I'm going to just do this at the side. So I don't care which way you do it. To me, the higher up you get in math, the more you want to be able to do that square part in your head. Okay, but I'm going to show you two ways. Okay, so if I FOIL this, I would have 9x squared plus 3x. And then the inner term would be plus 3x again. And then the last term is going to be plus 1. So that's going to give 9x squared plus 6x plus 1. Okay? Now, let me show you how to do this in your head. And a lot of you may know this, some of you may not know it. But here's how you actually do this in your head. What you can do is take that first term and square it. So what's 3x times 3x in your head? 9x squared. Okay? Then you take that last term and do that in your head. What's 1 times 1? Okay, we got that. Now what you do to get that middle term is you multiply those two things together. So you do 3x times 1, then you double it like that. Okay, that's a quick shortcut you can learn how to do. And the reason you double it is, notice when I did the FOIL over here, see how we had 3x and 3x? Well, if you double a 3x, you get a 6x. So what you can learn to do on a problem like this is, that's 9x squared, that's 1, that's 3x, double 3x, that's 2x. Does that make sense? So if you don't know that, that's worth knowing, but if you need to go through and do it that way, you can do that. I don't care. Okay, but you got to be solid with either way you do that. Okay, so what I'd have from here is, you want to bring this down as negative 6x minus 2, and then this would be 9x squared plus 6x plus 1 like that. And then we're ready to solve, so what's next? What do you do next? Move everything to one side so that you get 0. I'm going to choose to move these two things. So I'll have 0 equals 9x squared plus 6x plus 1 plus 6x, and then plus 2 like that. Okay, so that's going to end up giving me 9x squared plus 12x plus 3 is equal to 0. Okay, now there's a couple of things I want to make sure that you're solid on this. You could go ahead and factor now. How do you factor this right side? What's the first thing you see? You have a 3, right? So you want to take common factors out because it makes everything easier. So what we're going to go ahead and do is we're going to take a 3 out, and then that's going to leave us with 3x plus 4x plus 1. Whoops, that should be a 3x squared plus 4x plus 1 like that. Now actually that 3, you can ignore that 3 because you can actually just divide both sides by 3. I mean, you don't have to do that, but really you would have the equation 0 equals 3x to the second plus 4x plus 1, and then that's what you want to factor to solve. Okay, everybody with me there? Okay, so if you have a common factor, get that out of there because it'll make the rest of the factoring easier. So now what we do when we factor this, okay, the first term is going to be 3x and x. The last term is going to be 1 and 1. And once you practice this and get the hang of this, it's pretty easy in your head to see how the signs go. So this is just 1 and 3. If you're going to get a 4, they both have to be plus, don't they? So you could just visualize that inner and outer to get that to come together. Okay, is that okay? Everybody see how that comes together? Do you have a 4? Okay, see that's a 1x. Outside is 3x. 1 and 3 is 4. So you have 2 plus signs. Okay, so in your head, what are the two answers? Negative 1/3 and negative 1. I don't want to spend much time on that part. So yeah, your two answers are going to be negative 1/3 and then negative 1 like that. Okay. Now that's kind of what you want to get into when you're solving a quadratic equation by factoring. That's what you want to look at. Okay. Is there any question? Anything I need to clarify on that? Okay. All right. Again, I don't know any of you, so some of you may be totally on top of this. Usually when I start teaching this class, there's some students, they're just going like this the whole time. They may already know it. And then some students are looking at me like this because they hadn't been in math in 10 years. Okay, so I kind of want to make sure I take the time to try to get this right for everybody at the beginning. Okay, so let's go to what we call the square root property. This is something I want to review real quickly. And I want to do these two problems. Okay, now this problem right here, you could solve it by factoring. You could get one side equals 0, and you could do that. Okay, but it's better if you do this. See, you can get this x by itself, can't you? So if you can get x squared by itself, then you can do the square root of both sides, because what's the square root of anything squared? It's itself, right? So the best way to do this problem, the simplest way, at least, is to go through and divide by 2, and then that's going to give me x to the second equals 25. Then you do a square root of both sides, so that would be x. There is 2 answers, so you would have plus or minus square root of 25, so that means you have plus or minus 5. Okay, there's 2 answers to this problem. One is negative 5 and one's 5. And the reason for that is real simple. If you plug in negative 5 and square it, that's going to give you 2 times 25 anyway, right? If you plug in 5, it's going to work out the same way. Does that make sense? You square a negative number, you square a positive number, you get the same thing. All right, is everybody okay with that and clear with that? Okay? Okay, now let's look at this next one, because I just want to give a couple of examples of each kind of thing that you want to review. Okay, you have 2 choices on this problem. Choice number 1 would be to FOIL that. Okay, but what if you did the square root of this side? Wouldn't that just come off, that square come off? So the best way is anytime you have something squared equals a number, just do the square root of both sides. That's called the square root property, so we just do this, okay? Okay, that means the left side is going to be 2x minus 5. The square root of 121 is 11, but be sure you put that plus or minus, don't forget that. Okay, now it's just a matter of doing these 2 things. You get x by itself, so move the 5, and then divide by 2. So you've got a basic equation, and you want to kind of handle this like this. When you move the 5, you would have 2x equals 5 plus or minus 11. It's good to put that in front of the 11, not on the other side. Then if you divide by 2, okay, well, you're going to get x equals 5 plus or minus 11 over 2 like that. Okay, now you want to work that out because you're going to get 2 answers. Don't stop there. You want to go ahead and finish it. So what you would have from here is you would just do 5 plus 11 over 2. So that looks like that's 16 over 2, so that's 8. So that's the first answer. Then do the minus. Do 5 minus 11 over 2, so that's negative 6 over 2. So that's negative 3. Okay, so that means the 2 answers to this problem are negative 3 and 8 like that. Okay, those 2 problems I just did are the same thing. So what you want to learn to look for is if you have something squared equals a number, do it this way because it's faster. You see what I mean? If you took the time to FOIL that and factor it, you would get the same answers anyway, but it's more work. Okay, is that logical to everybody? So something squared equals a number, that's when you do square root property. Okay? Okay, now let's do a little review on the quadratic formula. I'm not going to do every problem with quadratic formula, but I'm going to do just kind of a few of them to review how to do that. So you want to make sure that you know the quadratic formula. This is the formula that will solve any quadratic equation, okay? But you want to factor when that's easy. You want to do square root property when that's easy. Any other time, you really want to do the quadratic formula. Okay, let's go ahead and do this one with what we call completing the square. Then I'm going to go through the quadratic formula. Okay, so I want to focus on completing the square on a couple of examples. Okay, then we'll do quadratic formula. Okay, so I'm going to work on number 23. Okay, one thing that you can write these steps if you feel you need to. The first thing you always do is you want the constant to be isolated on one side. So what I mean by that is when you do what's called completing the square, you have the square term, the first power, and then you have a constant. You want to have that constant by itself on one side. Okay. The other thing is you want to make sure that the number in front of x squared is 1. You have to start that way with those 2 things. Okay, so make sure that in front of x squared, is a 1, okay? That's how you must start the problem. There ain't any other way to start it, okay? So there's going to be times when you're going to have to move the constant to that side. If that was a 7 in front of x squared, you would have to divide by 7 to get rid of it. So that's how you have to start the problem, okay? Now let's see from our background if we remember this or not. So the next thing we do is we take that number in front of x. Do you guys remember from your background what you do with that number 12? You do two things. Divide by 2, and then what? Then square. Okay, so what you're going to do is you always take that number, and you do this mostly in your head. You take 12 divided by 2, which is 6. Then you square that to get 36. Okay, that's why we call it completing the square, because you end up with a perfect square like that. So what you do on your third step is you take the equation that I gave you, so that's x squared plus 12x equals negative 21. And see this 36, what you do is you add that to both sides of the equation. Okay, so that's kind of the key to the problem, is doing that. And then you'll kind of see how this works out if you haven't done this in a while. So you're going to factor that, and then you're going to put that together like that. Does everybody understand what I just did there? Okay. All right, so it's always start off with constant there, no number there, half of that and square it. So that's 6 squared is 36. Then do that to both sides. Okay? Now here's the way it works out. So now what you want to do is you want to factor the left side of this equation. If you factor the left side, you're going to have x and x. 6 times 6 is 36, and you're going to have 2 plus signs. Okay, and what will happen on completing the square is these factors will always be the same. Okay, it will never be different than that. That's why we complete the square. We want that to happen. And then this side is going to be 15. Okay, so what we really have is we have x plus 6 squared equals 15 like that. Okay, everybody with me there? Okay, what do I do now? Square root of both sides. Okay, it's like the thing I did just a few minutes ago. So you want to do that. So you want to square root both sides. Okay, so what you're going to end up having is x plus 6 equals plus or minus square root of 15. And 15 is just an irrational number, so you leave it alone. And then what you would want to do is move the 6 to the other side. And if you do that, you would have x equals negative 6, and then plus or minus that root. And you can write your answer like this. You could say negative 6 plus or minus square root of 15. That's a valid way to write that. Or you can list the two answers out. I think when you're doing problems like this on My Math Lab, you have to list the two out and enter your answer like that. I don't care on a test or something if you just write the abbreviated form. You just need to know what it means. Okay? So that's called completing the square. Now, when you solve a quadratic equation, the only time you really complete the square is if I tell you to. Okay? Most of the time what you're going to do when you encounter a quadratic equation, step 1 is to see if you can factor it. If you can't factor it, then you go to the quadratic formula. Part of the reason we do completing the square is because of other things we learn how to do in this class. So that's the idea. Okay? Is everybody okay with what I did there? Okay? Now I'm going to do just one more of those, and I'm going to do, then I'll do a couple of the quadratic formulas, then we got radicals and just a few things to finish up. I wanted to get this done the first half of class tonight. Okay, so this one, we're going to complete the square on this. Now, this one may factor, but that's not the point. So what did I say on complete the square that you have to do with the constant? That needs to be by itself on the other side, okay? So your first step with this one would be that you want to have, like this, you want to have z squared plus 12z equals negative 18. Okay, you start that way, okay? Now, what do you do with the 12? You take half of it, so that would be 6. I guess coincidentally it's 36 again, right? Half of 12 is 6, and you can do that in your head. You don't have to write that on your paper. So you're just doing 12 over 2 is 6. Then you're doing 6 squared is 36. Okay, and then what you do with that is you add that to both sides. So you have z squared plus 12z plus 36 equals negative 18 plus 36 like that. Okay, now this one's going to factor just like the one we did before. That's going to be z and z. 6 times 6 gives you 36. and you have two plus signs. Okay, then the right side, it looks like that's going to be an 18 like that. And I'm glad this is working out this way because there's one little thing I want to make sure you know how to do. So we would write this as z plus 6 squared is equal to 18. Okay, now what? Square root property. Okay, that's the whole point behind that. So you get square root, and don't forget to put a plus or minus, so that has to be in there. So what you would have from here is you would have z plus 6 equals plus or minus square root of 18. Okay, now we've talked about this before. Square root of 18 you can simplify. Okay, what is a number that divides into 18 that is also a perfect square? Right, 9. 9 times 2. You want to break that up into 9 times 2 so you can simplify the radical. We talked about that a little bit last week. So you want to write this like this. You want to say z plus 6 equals plus or minus square root of 9 times square root of 2. Don't do 6 times 3 because 6 and 3 are irrational numbers. 9 is the magic number you want, see. So now what you're going to have is, from here I'm going to have z plus 6 is equal to plus or minus 3 root 2. And then the last step is just to move the 6 the other side. So you would have z equals negative 6 plus or minus 3 root 2 like that. That's it. That's your abbreviation. Okay? So that's something you want to make sure you're on top of. You'll do that all semester. Even when we get to the trig part, you'll find that you'll be simplifying radicals all the time. So you want to be totally on top of that. Okay? Okay, now I'm going to do just one quadratic formula problem. The reason I'm only going to do one of those is students generally do not have much trouble with the quadratic formula, okay, compared to some of these other problems. So I'm going to pick one of these out. I think what I'm going to do is just do number 28, and we're going to do this with the quadratic formula, okay? Just kind of to remind you on that. Then we'll move on to radicals, and then we'll be about done with this. Okay, what's the first step on number 28? Now, one side equals 0. Okay, good. So you want to make sure that you go ahead, move those two things over. You can do that in your head. So that will be 2x squared plus 2x plus 5 equals 0. Okay, now I'm pretty sure that doesn't factor. If you tried, you probably wouldn't get anywhere. So what you do in a quadratic formula, a is the number in front of x squared, b is the number in front of the x, and then c is 5. You want to make sure before you go to the quadratic formula that it's in standard form. One side's equal to 0. Okay? So we have the formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, then you just plug in and calculate. And usually students do fine with this, although sometimes there's some issues at the very end of that. Okay, so it's going to go like that. B is 2, so you'll say negative 2. Underneath the radical, you're going to have b squared. B is 2, so we're going to do 2 squared. Minus 4 times a, which is 2, times c, which is 5. And then there's a big fraction bar, and that's all over 2 times a like that. Okay, students always do that fine. That's not an issue for students. Plug in the formula and calculate. Now, let's see what we got here. This would be negative 2 plus or minus square root of 4. And then this would be 8 times 5. So that would be 40. And then that would be over 4 like that. Okay? Now, we haven't talked about this yet. We're not ready to talk about this yet. So at this stage, I'll tell you what we're going to do. This right here would be negative 2 plus or minus square root of negative 36 over 4. At this stage in the class, because we don't talk about imaginary numbers till later, what do you know about the square root of negative 36? It's an imaginary number. You can't do a square root of negative 36, right? Okay? But you probably know that it's 6i. Do you guys remember that okay? Okay? So there's two ways that you could do this, but for now, all you got to do for now is, since that's negative, you just say there's no real solution. At this stage in the class, that's good enough. Okay? That's the idea. All right? Okay, so that's quadratic formula, and you'll probably be able to do that fine when you do that. Okay? Okay, I'm going to go a little bit to radical equations because I'm not going to do everything in here because we need to kind of get this wrapped up so then we can get into the material of the class starting in chapter 1 tonight. So I'm going to go through a little bit with, instead of discriminant test, that's not as important as just knowing how to solve radical equations. So I'm going to go ahead and do the radical equations. Then we want to kind of skip through and get the identities done, okay, or the inequalities. Okay, so the next thing we're going to look at is an equation that has a radical in it and kind of review how you do that. When you're doing equations with radicals, what you always want to do is you want to isolate the radical. It's a lot like absolute value. That has to be isolated, okay? So what I mean by that is if you look at the left side of the equation, there's nothing outside of the radical, right? If there was like a 2 plus that, then you would have to get rid of it. You want nothing outside of that radical on that side of the equation. So it is isolated. Everybody understand what I mean by that? Okay? Now, what do you do to make that radical go away since it's a square root? Okay, you square both sides. Okay, so you want to do that. And what happens is, and you don't have to write this step, but I want to explain why this works, is we've already said many times that when you square root something squared, it undoes the square, right? So the radical goes away. So you end up with 4x minus 3 is equal to 9 like that. Now it's an easy equation that's easy to solve. So you can just do, and you can do some of the steps at the end in your head. I'm fine with that. You're just adding 3 to both sides. You would have 4x equals 12. Divide by 4, so you'd have x equals 3. Okay? And what's important on these problems is to check them. Every now and then, your answer doesn't check. Okay? And that will happen sometimes, but it ain't going to happen on this problem. So that's a real straightforward example of a radical equation. Okay, is everybody okay with what I did there? Okay, all right. I want to do, I think, one more radical equation. Then we're going to skip to the inequalities. And on the word problems, I'm just going to set those up a little bit here. Okay, so if you look at this problem right here, I just want to give you 2 examples of this. What would be the first thing that you would have to do on that problem? You have to isolate the radical, right? So that means make that 6 go to the other side. Just add 6 to both sides. So you would have 20x plus 20 is equal to x plus 6 like that. Okay, this equation is going to work out the same way. It's going to have a little bit more involved in it. So now you're ready to square both sides. Okay, like this, the radical is going to go away. That's going to give you 20x plus 20. And then on that right side, what are you going to do? You got to FOIL it, okay? And you can either do, I'm going to do the shortcut. You don't decide which way you like better. You can write it out twice if you want to. But here's how the shortcut goes. X times x is x squared. 6 times 6 is 36. And then if you take x times 6 and double it, you get 12x. So you can do that. If you want to start doing that shortcut, you're more than welcome to do it. If not, write it out twice and FOIL. You see what I mean there? Okay. So this is a quadratic equation. So that means that we need to figure out one of the sides needs to be 0. So you would end up having 0 equals x squared plus 12x plus 36, and then minus 20x, and then minus 20 like that. Okay? So basically we'd have 0 equals x squared minus 8x. Then that would be plus 16 like that. Okay, collecting like terms. This one factors, so since it factors, we want to go ahead and do that. So you would end up having x and x to get x squared, 4 and 4 to get 16, 2 minus signs, so what's the answer? 4. There's only one answer too, it's 4. Okay, so that's it, okay? And then typically what you want to do on these things is you want to plug it in and check and see if it works. So I'm not going to do all the checking on that, but that's what you need to do when you're doing a radical equation. Okay, is there any question on that? Okay, everybody okay? Okay, you okay back there? Okay.
Could you go over how you quickly find 12x again?
Yes. Okay. Because what I did on this is when I do the shortcut, I multiply 6 times x, and that's 6x, right? Then you double it. So if you double a 6, you get a 12. That's the shortcut if you want to do that. If you practice that, you'll start doing it second. It won't be anything to you, okay? Okay, I'm going to skip through these word problems, and we're going to do a very quick review of absolute value of inequalities. Okay, and once I do that, we're pretty well wrapped up, okay? So I'm going to go down to do kind of a quick overview of how you solve inequalities. And you're going to do this all throughout the semester. So the first thing when you're doing an inequality, it's just like solving an equation. Okay, so the first thing is you don't want the 1 there, so you can just subtract 1 from both sides. And you can do that in your head. So you'd have 4x is less than 36. And then if you divide by 4, you would have x is less than 9. So inequalities, they only are going to have one little slight difference to them that I'll talk about in a minute. So you also want to remember this. Now this is real important in this class in calculus, is you do a graph of a number line. So if I have you do a number line, all I care about is you put 0 and you put 9. You don't have to put all those little notches. I don't care about that. So this is less than. So less than means all of the numbers that are less than 9 are to the left of it. So what you do on this is you put a parenthesis there, right on the 9, and you draw your graph like that, okay? Now what this means is, see this thing right here means, since it doesn't have an equal to bar, it means that you are exclude the 9. That's not a part of that solution, so it goes like that, okay? If that was a equal to, let me just see what you guys remember from your background. If that's an equal to, what's the difference in the graph? It's a bracket. And a bracket means it includes that. Okay, so if you got no equal sign, and I gave you this chart that kind of shows that. So that would be a parenthesis versus a bracket would be if you have the equal to bar like that. Okay. The other thing you want to review is how you do interval notation. So when you do interval notation, it kind of goes like this, okay? You always name things from left to right. So you're going to have like, where does it start? Where does it end? Okay, so it just kind of goes like this. So just on a quick review on this, okay, this thing goes forever that way. Okay, so what's the symbol for forever that way? Negative infinity. Comma, then it ends that way. So if you're forever to the left, then your interval notation is going to go like that. You have a parenthesis, negative infinity, comma, ends in 9 like that. Okay, you guys remember that? Okay, so you want to be totally solid on that. That's incredibly important in this class in calculus, okay? Okay, let's look at a couple of more things on here. And let's see what we remember on this one. I'm going to go ahead and do this problem. Then I'm going to go ahead and finish up with absolute value. And that's as far as I'm going to go with this, okay? So I have negative 9x greater than or equal to 63. Okay, I just want to see if you guys remember this. Now, the way you would do this is you would end up dividing by negative 9, right? You would have to. So what happens is that gives x, that gives negative 7. What do? You got to flip the sign. That's something that you want to remember, is any time that you multiply or divide by a negative number, you have to change that sign like that. The reason for that's real simple. I can show this real easy if you've never understood this. So like if I had 2 as less than 4, you know that's true, right? Look what happens if I divide by negative 2. Then I would have negative 1 and negative 2. That's no longer true, is it? It's that way. So anytime that you divide an inequality by a negative, that sign's got to change. You've got to really pay attention to that when you're doing this. Okay, everybody got that? Okay, so you do that. So the answer would be x is less than negative 7. And then what you would have on your graph is this would go like this. So you would just have 0, just put negative 7 somewhere. This time it's a bracket right on the 7, and then shaded forever to the left like that. Interval notation on this one is going to be forever to the left is negative infinity, comma, negative 7 with a bracket. And one thing I see students do a lot is put a bracket on infinity. You never put a bracket on infinity because that's implying, like this is just saying that 7 is a solution. Negative 7 is a solution, whereas if I had a parenthesis there, negative 7 would not be a solution. A bracket includes, parenthesis excludes. So don't ever put a bracket on the infinity, okay? Okay, so I want to kind of go through that, and then to finish this up, I want to just do a little bit of absolute value. So the key thing that you want to know about inequalities is how to solve and graph and do interval notation. So I'm going to go ahead and do a little bit with absolute value inequalities. I'm going to just do the real basic ones and then a couple of the ones that we got to set up. So I'm going to start by doing 37 and 38, okay, because this is the basic. And you want to understand how this works out. So what I'm going to do on this, instead of just showing you how to do it, because ultimately I'm going to show you how to do it, this is what happens in this problem. So draw a number line, put a 4, a 0, and a negative 4, okay? Now, one thing on this is the answer falls somewhere on that number line. Okay, so first of all, we're going to look at it this way. If you plugged in a 4 and you did absolute value of 4 is less than 4, that's false, isn't it? Okay, that doesn't work. But what if you put 3? 3 is less than 4. Does that work? Absolutely. So you're going to have, like at 3, yeah, you're going to have an answer there. I'm trying to show you the why part of this. And then what would happen, and we're just going to do this in our head. Okay, so if you had 2 is less than 4, that works, right? 1 is less than 4, 0 is less than 4. Then you have negative 1, right? But you do the absolute value of negative 1, which gives 1. And 1 is still less than 4, right? So a lot of times students are going to think, well, it's just from there forever. No, it isn't. Look what happens when you get out to negative 5. The absolute value of negative 5 is 5. Is it true that 5 is less than 4? No. So that means your answer is contained between those two numbers. Does that make sense? Because once you get out here, remember, you're doing the absolute value, and that's going to be larger than that 4. So the way this one works on a graph is it goes like this. You would have a parenthesis on 4, a parenthesis on negative 4, and then that's your solution. Okay? When you write that in interval notation, you're going to say parentheses, negative 4, comma 4, like that. Okay, that's how that works. Okay, so try to think of an absolute less than as kind of between two numbers. Get that in your mind, and that'll help you remember how to set that up. Okay? Now, let me ask this question, because the next problem I'm going to do is greater than. What is the opposite of this solution? The opposite of here is there, right? Okay, so when you do a greater than problem, it's just going to be there forever and there forever. That's the only thing that would make any sense, because they're opposite of each other, okay? So when you get to doing this number 38 up here, okay, then what we're going to have on this, if you draw a number line on this one, it works like this. There's 7, there's negative 7. So one solution is bigger than 7. The other solution is smaller than negative 7, like that. Okay, it's the only thing that would make any sense. Okay, nothing in the middle of those numbers would work. When you do interval notation, you would say 7 to infinity. Then you would say negative infinity to negative 7. And then the correct way to do that is put a U between that. That means set union. So you want to put that like that. That's how you write the solution to that kind of problem. Okay? So try to think in your mind that absolute less than is a small distance. Absolute value greater than is a big distance. That's the idea. Okay? All right? Now I'm going to just pick one of these out, and I'm going to do this one, and then I want to do this greater than. Let's just do these two, and that should be good enough. Okay? Okay, so let me show you what you would want to do on this then. Okay? So like all these problems, the first thing that you want to do, just like on radicals, is you want that isolated. Because you don't want to set it up until it's isolated. So the first thing to do is just move that 6 to the other side. Okay, you have to isolate. That's always step 1. Okay, so that is absolute value x minus 7 is less than 1 plus 6. So that is absolute value x minus 7 less than or equal to 7. Okay, now I'm going to show you how to set this up. There's more than one way to teach students how to do this, but try to think in your mind that the answer is going to be between two numbers. Okay, so set it up like this. Once you have that isolated, just do this. Put a 7 and put a -7. Put two less than symbols, and then whatever's inside of this, just put it right there. This is the simplest way to kind of get you going on how to do that problems like that. Okay? And what will happen with this is now, this is what we call a three-part inequality. So you want to get rid of 7, so you got to add 7 to all three parts of that. Okay, because you got to get that x in the middle like this. So the way this works then is like this. You would add 7, add 7, add 7, and then what you would have is this would be 0 less than or equal to x less than or equal to 14. That's the answer to that problem, as it falls between those two. Now, the only way you can really understand this, I mean, you can understand how I do this, but I want you to just see if you can do something in your head. This is easy. Take that 0. What's 0 minus 7? -7. What's the absolute value of -7? 7. 7 minus 6 is 1. So that's correct. Now what would happen is if you picked a number below 0 and plugged it in, it wouldn't work. Let's take like -1. You can do this easy. What's -1 minus 7? -8. Absolute value of -8? 8. 8 minus 6? 2. 2 is not less than 1. That's the only way you really make sense of this, is to do that. And then the same thing would happen there. If you plug 14 in, 14 minus 7 is 7. 7 minus 6 is 1. If you took 15, it doesn't work. 15 minus 7 is 8. 8 minus 6 is 2. 2 is not less than 1. Does that make sense? That's how you understand what's going on. But the methodology of doing that is, if it's a less than problem, get it isolated and set it up that way. That way you can get your answer immediately without having to do anything else. Okay? So what this would end up being on a graph, you would just have 0, you would have 14, and then what you'd have is bracket on 14, bracket on 0, and that's how your graph would look. Okay? Now let me just ask this to make sure you're clear on this. Is 0 an included solution on this problem? Yes or no?
Yes.
Yes. Is 14?
Yes.
Yes. So it's 0 and 14 and everything in between. Okay? If that had a less than, then it would have parentheses, so they're not included. Everybody with me there? Okay. Okay, let's do one thing here, and we'll take a break, and then we're going to be ready finally to get into the chapter. Okay? See, when we teach college algebra at CU Denver, we spend like about 3 weeks on this material. Okay? Here at this class is like 2 class periods, or maybe 2.5. That's it, because everything's condensed. So the idea is we're kind of hoping that your background is sufficient so that you can do this review material pretty quickly. So let's go ahead and let's do this one. So I want to do 1 greater than. Okay, like that. Okay, so let's go through and just finish up by doing this problem right here. Okay, first thing you want to do is what? Isolate. The 8 doesn't need to be there. The 8 needs to go the other side. So you would have absolute value 1 minus x over 2 greater than or equal to 10 minus 8, like that. Okay, that's going to give you 1 minus x over 2 greater than or equal to 2, like that. Okay, now here's what we said. If it's a less than absolute value, the answer is here. What's the opposite of here? There, okay? So that means what you do is you set this up like this. You say 1 minus x over 2 is greater than or equal to 2. See, that gives you the solution that's going that way. And then you got to have the solution going the other way. So you're going to say 1 minus x over 2, and you do 2 things. You do less than, and you do -2. Like that. So you're always changing that number, but you're also changing that sign. Less than's that way, greater than's that way. Then if you solve those 2 inequalities, then you have it. Okay, that's how you want to set up a greater than problem, is like that. After you isolate, you always have those 2 inequalities to solve. Is everybody okay with that? Okay, all right. So let's go ahead and finish this up then. And this one right here, you got to be kind of careful on. So I'm going to move the 1. So I'll have negative x over 2 greater than or equal to 2 minus 1. That would give negative x over 2 greater than or equal to 1. Now you got to be very, very careful on this problem. Okay, well, you got to get rid of the 2, right? And you also got to get rid of the negative. The simplest way to finish this problem up is to multiply both sides by -2. And by doing that, you're going to have x, and you're going to have -2. But don't slip up on this. What have you got to do with that? Got to change it. Anytime you multiply or divide an inequality by a negative, you have to change that sign, because all the numbers are going backwards now. So what you would end up having from here is you would have x is less than or equal to -2. Okay, that's how that goes. Be really, really careful on that. Okay, this other part right here is the same way. You'll have -x over 2 less than or equal to -2 minus 1. That's -x over 2 is less than or equal to -3. And then you're going to multiply both sides by -2 to get rid of that fraction. Okay, so all I'm trying to do is just get rid of that negative and get rid of that fraction. So that will be x. What do I do with the sign? Change it, greater than or equal to 6. So it goes like that. Okay, so if you went through and put this together, if you graphed this, this is how this would look. You would have a 6, and you would be greater than or equal to 6. So you'd be going like that. You would have a -2, and you'd be going to the left like that. So that's how that goes, okay? And then you would do your interpretation from there. Okay? And one thing, if you really want to get this stuff down, just check, okay? Like you can plug the 6 in, and you can go way back to the beginning and you can see that that works. So 6 works and everything there works. -2 works and everything here works. It's all this stuff in here that would not check in the inequality. Does that make any sense? Okay? And this is kind of thing in a different class. I can teach this more in depth. Like this is just reminder stuff for this class, okay? So how you feeling? You're going to be okay once you do your homework. And I'm serious. If you do this homework on this P chapter and do good with it, there's absolutely no reason why you shouldn't do good the rest of the way. I'm not kidding about that. Because that's all the basics. Everything else depends on how well you do this stuff. Okay? So you want to be sure you work very hard on that. So let's take a 10-minute break. And then we'll come back and we'll get into chapter 1. We'll start getting into the stuff we're learning. This is all review up to this point.